GraphQL and REST APIs represent two distinct yet powerful approaches to API design. GraphQL, introduced by Facebook in 2015, has gained significant popularity since its inception. While REST APIs continue to be the go-to choice for many, there are specific scenarios where GraphQL shines as a more effective solution. In this video, we'll kick things off with a brief overview of GraphQL for those who might not be very familiar with it. If you already know what GraphQL is, feel free to skip to the section on its applications. A bookmark is included in the description below. Next, we'll explore the similarities it shares with REST APIs before diving into the scenarios where GraphQL can truly outshine REST. We'll also discuss instances when using GraphQL might not be the best fit. So, what is GraphQL? GraphQL, in short, is a query language for your APIs. What do I mean? Let's understand it by first talking about REST APIs and then see how GraphQL is different. So let's say we have two entities in our application, which is a store application for a chain of stores like a Home Depot or a Best Buy or something like that. The employee entity has attributes like ID, name, and store ID for the store where the employee works from. And then we have the store entity, which has attributes like ID, city, and name. Now, we would generally create CRUD REST APIs against each entity with the normal HTTP operations of get, post, put, and delete. Now, let's say our app needs a JSON structure like this, which includes the ID and name from the employee entity and the city from the store entity. Let's say we have 20 employees, so our app will get the 20 employees in one get call, and then for each employee, make a get call against the store entity to get the city. So, 21 calls or multiple round trips to get the required data. Further, it will get all the attributes of the entities even though we may not need them all. For instance, we do not need the store ID from the employee entity and the ID and name attribute from the store entity, but these will be fetched regardless, leading to overfetching and a larger response size. With GraphQL, we will issue a query like this where we specify the structure and the attributes we need, make one call, and get all the 20 employees with the city of their store in one go in the final structure we need. So certainly it is more efficient, reduces multiple round trips, there is reduced overfetching as we just get the attributes we want, and it also exposes the schema and the available queries to the client, providing documentation of what is available to call. When it comes to facilitating data exchange, both REST APIs and GraphQL share some key similarities. Both enable seamless communication between clients and servers, allowing different servers or applications to share data effectively. Each operates on stateless calls, meaning every request contains all the necessary information to be processed independently. Both use HTTP as their foundation, though REST employs various methods get, post, put, delete, while GraphQL primarily relies on the POST request. Both allow clients to query and modify data, but GraphQL lets clients specify exactly what they need in a single request. Both can return data in popular formats like JSON, XML, and HTML, making them versatile for various applications. Here are some use cases where GraphQL can give us benefits. GraphQL is ideal for mobile apps and IoT devices where bandwidth is limited. It allows clients to request only the data they need, minimizing data transfer and enhancing performance under slow network conditions. If your application involves complex schemas with nested data, GraphQL excels at fetching related data in a single request. For instance, in social media platforms or blogs, where you might need to retrieve posts along with comments and user details, GraphQL can streamline this process by consolidating multiple requests into one. When your application aggregates data from various APIs or services, GraphQL can serve as a unified interface. This is particularly useful for dashboards that pull information from different backends, allowing for a more cohesive data retrieval strategy. If client requirements frequently change or vary significantly, GraphQL provides flexibility. Clients can specify exactly what data they need without requiring changes to the server endpoints, making it easier to adapt to evolving needs. With its strongly typed schema and introspection capabilities, GraphQL enhances the development experience by providing better tooling support and reducing runtime errors through type validation. However, there are certain scenarios where using GraphQL may not be the best fit. If you have smaller applications which have less complex data, REST might be a simple and more efficient choice. When most of your clients use the data and operations similarly, and you need not run dynamic queries, then REST might be better. Caching in GraphQL is more complex due to its single endpoint and dynamic queries. Unlike REST APIs that can leverage HTTP caching effectively, GraphQL requires more sophisticated strategies for caching. So if your application relies heavily on caching, then using REST APIs might be better. If your team is more experienced with REST and not familiar with GraphQL, the learning curve might slow them down. Understanding query syntax, schema definitions, and optimization techniques takes time and effort. For simple applications that perform basic CRUD operations, the overhead of implementing GraphQL may be unnecessary. In such cases, REST APIs provide a more straightforward and cost-effective solution. REST has a mature ecosystem with a wide range of tools and libraries. If you rely heavily on these tools, sticking with REST might be beneficial. The ecosystem around GraphQL is still maturing compared to REST. So hopefully, this video provides you a good understanding of what GraphQL is, how it is similar to REST, what are the use cases when it can be beneficial, and where it does not make sense to use it. Thanks for watching.